Hi everybody, my name is Monica Costa. I am a technical solution architect for GBE Software POV organization.
I'm a friend. I'm part of the GSP America Mobile, and I'm a C software engineer.
Hi, I'm Gabriel. I'm a C collaboration team support engineer for GSP America Mobile.
Hi everyone, my name is Abraham. I'm also working with the programmability team, GSP America Mobile, and we are the Mexican team representation.
For our project, we take a situation that a lot of customers have in their networks. They have the best of breed, which involve a multi-vendor architecture, monitoring tool that use SNMP that limits the KPI due to the MIPS of each devices. Tracking an event from the networks involve many manual operations, such as constantly review the management system, send emails, and create a ticket for service desk that involve long time to response. Thus, we review APIs and automation tools, and we suggest taking the same scenario with multiple vendors, but review which of them support telemetric or API to access by Python scripts beside the MIPS from SNMP. Customize the information that customer needs and avoid the MIPS info limitation and create customized dashboards. Automate process when an event happens, such as create a bot that aware network situation, create a ticket for service desk and contact a support escalation contact, reducing time to response, and create agile process to execute remediation actions.
Hi guys, this is a friend. I will explain the initial requirement of this project and the problem our customer has, right? So they wanted to obtain their data from their devices in their production network the fastest way possible. So the current data could be only obtained at this moment via SNMP, and the time they obtain this is every 15 minutes. So as you know, this is a lot of time for them. And so in order to these requirements, we develop a Python script and we make a connection via SSH. So the first thing is to know which device we are connected. For example, we are doing this proof with an ACR 9K, and in this line we are putting or we are writing the our credentials and the IP address. So when we make this, we also need to save the data we are going to pull out of the device. In this case, we are doing this with an InfluxDB database. And when we have this, I will explain this code. Here we are. So the first thing we want to pull out is the bandwidth. So that's why we have the output packets of the device. Also, we are going to pull out the CPU information data. And finally, we are going to display the quality of service in the dashboard. And we put some throughput into the device in order we can make some measurement into the future dashboard that we are doing. So how are we doing this? In the CLI, we have the commands in order to pull out this data. For this example, we make with a 10G interface, and the same for the CPU and the same for the policy map interface, right? So now that we have this data, we are going to save this information into a database. As I said earlier, we are saving this into an InfluxDB database in order to convert this data into a timestamp. So now that we have the data points, we could display this information into a dashboard. We are going to display this into our Grafana dashboard. And that I'm going to show it more later. So this is our code that we developed for this project. Now this Python script is saved into an UCS server with a CentOS as an system operating system. Then we make a shell in order to have this running every 30 seconds. So as you can see here, we have the script running, and here is collecting the data that we are pulling out, and here is connecting. So we have here all the information that we need to store into our database, and the script
part, we have SNMP, where we can make graphs with this information that we obtain. What do we use? First, we have the devices with iOS XR or iOS SE. These devices send information by SNMP from the devices to the database. In this case, we use InfluxDB. We also use Telegraph that makes the connection between the devices and the InfluxDB. After, Influx has received information, processed to save it in the database. Finally, Grafana extracts the information from the InfluxDB so that it can display the data in the customized dashboard. As you can see, with SNMP, we don't have any information of QoS, so this data is empty.
Hi everyone, I'm Abraham, and I'm going to show you how our bot solution is working. Of course, it's working over WebEx Teams. We use the WebEx Teams API, and to start a conversation or to know what the Enigma, which is the name of the bot, can do for us, we start typing hello. And that's the answer of Enigma. Enigma gives us three options at this point: call a support engineer, show the bandwidth, and CPU. We are going to show you, I want to know what is my bandwidth. And Enigma answered with the bandwidth and over which interface is that bandwidth at this moment. This information is in real time. Other option, number 3, our CPU is actually at 6%. That's the average over the last 1 minute. Last minute, our CPU was running over that average. But what happens if we are out of office and something is wrong with our box? Enigma can send us an alert about what's happening. In this case, it's related to our bandwidth, probably the bandwidth is reaching a high level, not a desired level, and we can take an action. We can also call a support engineer or create a support ticket for our team, which can solve the issue. So we just type the number 4, and Enigma create a support ticket with a number, and we'll send an email with to our team, and that's it. Enigma sent an email to our support team, which can take an action to solve the issue, generate a ticket, and this is the email that our team receives. My ASR is having a high bandwidth and the ticket number. And Enigma at this point is programmed for send an alert for our CPU. The same as bandwidth is in case our CPU is reaching a higher level, and same actions. Call a support engineer or create a support ticket. And finally, and our favorite part of the bot, is what happens if Enigma sends us an alert. In this case, it's related again with our bandwidth, and we want to take an action calling a support engineer. Well, we just need to type number 1, and Enigma will give me an URL where I just need to put my credentials, an engineer's email. We are going to select what kind of communication do we want. Here we are in our dashboard. And here we go. We just need to Hi, Moni. Hello, Moni. How are you? Fine, thanks. Unfortunately, I'm having some issues with my ASR. Could you help me? It's related to bandwidth. Yeah. Okay. Thanks, Moni. Have a nice day. Bye.
It is important to say that Enigma not only works over WebEx Teams desktop application, you can use Enigma with your cell phone. For example, we are going to type again hello, and that's the answer. We can check our we can make a call support engineer, check our bandwidth, or check our CPU average. And now the important here is what happens if we are, as we said, out of office, and here you have it, a notification warning us about something wrong with our devices.
Thank you for watching us.
Please support us.
Vote for our idea.
And that's all, everyone.